Mars, the crystal planet. After stumbling across Neville Thompson's Mars Gigapans in February 2016, I, along with thousands of other people, became fascinated with exploring this planet. I was immediately struck by the number of squares and rectangles, both large and small, that I was seeing in many of the places I looked. They appeared like buildings, aircraft hangars, or dwellings. My imagination began to run wild, as people, including me, found faces, bodies, skulls, bones, and nearly anything one could imagine, but I kept seeing these geological structures. Sheets of lattice-like structures, some just laying there, some embedded in rock, some looking like little crystal boxes, and a few in piles looking all broken. Many were translucent and reflected the sunlight, glistening in some areas. Others were dark and burned looking. I tucked it away in my mind, wondering what they could be. Then one day in late February 2016, I saw Neville Thompson's Gigapans from MOC, the Mars Orbital Camera, of Airy-O crater. A light bulb went on as I was seeing the same structures in the bottom of the crater that I was seeing on the surface. Crystals. It made sense, at least to me, that the weaker, smaller webs of crystals would be ejected by meteor impacts or volcanic eruptions. In addition, the stronger, larger crystal webs would remain in place, allowing lava to be extruded through them, whatever shape they would be, and be deposited on the surface as ejecta. On April 13, 2006, the Mars Orbital Camera, MOC, took these magnificent images from over 12,000 feet. These gigapars were stitched by Neville Thompson. Please use these links below to see for yourself what lies deep at the bottom of Airy-O crater as you zoom in. In my humble opinion, these could only be gigantic crystals. These existing crystals were strong enough to withstand the impact of a meteor and stay intact, ejecting everything else. They must be carbon or carbon-like crystals, and range in size from small to megalithic. Airy crater is approximately 27 miles in diameter and is approximately 1.5 miles deep. It is located at 0.1 degrees E 5.1 degrees S in the Meridional region. The much smaller crater Airy-O, which defines the location of Mars' prime meridian, lies within it. Airy-O crater is approximately 0.31 miles in diameter and approximately 1.25 miles deep. That places the bottom of Airy-O crater at approximately 2.30 miles below the surface of Mars. Two new kinds of ultra-hard carbon crystals were found embedded in a Finnish meteorite in 2010. The Airy-O meteorite crashed to Earth in 1971. It landed on the island of Airy-O, 25 kilometers southwest of Turku, southwest Finland. When researchers used diamond paste to polish a slice, they noticed something extraordinary: small pockets of material emerging in relief from the surface. When they analyzed the stubborn crystals, they discovered two completely new forms of carbon. Diamond is so hard because the carbon atoms inside it are arranged in a tetrahedron-shaped lattice that is immensely strong. In Airy-O, the researchers found crystalline carbon arranged in a rhombohedral lattice. This type of diamond was predicted to exist decades ago but had never been seen in nature. The second substance turned out to be a totally new kind of crystalline carbon, which the researchers call an intermediate between graphite and diamond. The crystals are so small that no one has been able to test the limits of their hardness. Graphite, like diamond, is made up entirely of carbon atoms. However, its atoms are arranged in honeycomb-like sheets. The sheets are only weakly attracted to each other, making it soft and slippery. When the meteorite entered Earth's atmosphere, the researchers think pressure shocks and intense heat fused sheets of graphite together, much like the way labs make artificial diamonds. Unfortunately, the crystals are so small that no one has been able to test the limits of their hardness, nor compare them with the artificial ultra-hard diamonds lost daylight and boronite.